Today we're going to talk about a totally new topic known as inheritance. To set the stage, let's consider the S-list class and the A-list class that we built over the last so many lectures. So we see that they have actually the exact same operations. They both let us add things, get things, remove things, get back the size, and if you did the discussion worksheet available on the website, or if you're in the class at Berkeley, then we added this insert method. They can insert to an arbitrary position. Okay? So given these classes, we now want to try and actually use them to do stuff. So what's something we might want to do? Well, let's just make a little tiny pretend problem, which is that we want to build a library to help other people process lists of words. So maybe we want to write a method that takes a list of words and it finds the longest word and returns it. Okay. Now this code right here, it does not actually matter what it says. Don't worry about reading the implementation here. Just trust me that it works. Okay. So when we look at this code and we try and run it, this is an example, a test drive of this library. So if I create an S list and I put in the words elk are watching, and then I ask for the longest word, and I click run word utils, then I get back watching because it is the longest word in the list. Now there's a little bit of an issue here, which is that maybe someone out there who had a list of words, they didn't read it into an S list. Maybe they did an A list instead. So let's simulate that process. So if we do this, and we look at what happens after we change from S list to A list, we of course get an error. The error is that, well, we can't give A lists to this method. So a pretty short little problem that I want you to consider. What do we need to do so that A lists work? What can we change about this code? Okay. So in this case, there's not a lot that we need to change. In particular, we can just change SL to A. So in other words, I do that, and now things will work just fine. Okay. So same idea. Everything works fine in this case. Now, of course, it would be annoying if somebody trying to use our library had to constantly edit A list to S list. So another solution would be to actually just make another copy of the method, make this one A list based, this one S list based. And in this case, even though these two methods have the same name, it's okay. This code will compile just fine and work because that's something you can do in Java. So this idea of having multiple methods with the same name, but different parameters or different signatures, that's fine. Java will automatically, at the time you compile, figure out which method's going to get called, and it will know which one's going to run. And so this is just known as overloading. Now this is not great. Although it works, this is a very crude solution. So while overloading does technically work and it lets us run our code in either case, I think it's terrible. And so I want you to ponder that. Like, why is it bad? Maybe come up with a short list, and I'll spoil it with my list. So some things I don't like about it are that, one, our source code files, of course, are unnecessarily long. You look at them and you have all this extra stuff. That might not necessarily be a big deal, but it makes it messy. Another is, it's just aesthetically terrible to repeat yourself, right? I mean, not only is the code long, but it's so similar. Nobody wants to, it just doesn't feel right. Another one is that it's more code to maintain. Now this is an interesting point, right? Code doesn't really need maintenance in the same way that a car needs maintenance. It's not like, oh, this code's gonna get rusty and we gotta go fix it. You don't have to come back in and fix, like it changed to Zist for some reason. That's not a problem we have with computers, thankfully. But if anything ever does change, if we realize, oh, this isn't efficient, and someone makes a change to one of these, then you also need to make a change to the other, or any other number of little changes. So any change you make to one must be made to the other. And this matters not only just for efficiency reasons, but any bug fix. So a common mistake in large projects is somebody's written a method that has some kind of bug in it, and there's another very similar method, and they only track down and kill the bug in one of the methods, and the other one continues to live on. That's a very dangerous thing that can happen when you have repetitive code like this. The other one, the final thing I want to mention is that suppose we decide I don't like just A lists and S lists, but maybe I also like D lists. In that case, we'll actually have to come along some later date and write another dlist function. So this lecture is going to be about how we can gracefully deal with this issue and take advantage of what we get as a result. That will be inheritance.